quotient rule. So just like the product rule, the quotient rule, we can't just take the derivative of the top and then put it over the derivative of the bottom. Okay, it doesn't just work like that. Okay, so here is the quotient rule, and we're gonna actually solve for like the proof of this. Okay, so originally we'll have h at x equals f at x g at x over g at x. Okay, let's cross multiply. So now we have g at x, h at x equals f at x. Okay, let's apply the product rule here. So we have g prime at x, h at x, plus g at x, h prime at x. And this equals f prime at x. Okay, what we wanted to do from the beginning is we wanted to get h prime at x. So what we want to do is we want to get this, this term alone. So let's rewrite g at x, h prime at x. Okay, we have f prime at x. And let's actually bring this over to the other side. Minus g prime at x, h at x. And then we're going to divide it by g at x. All we're going to do now is a simple substitution, okay? So this g prime at x this h at x, what we're going to do is we're going to sub in f at x, g at x. Okay, so this is what we have so far. We have h prime at x equals, and that's what we want. We have f prime at x minus g prime at x times f at x over g at x. And that's all over g at x. So let's find a common denominator here. So g at x is going to be the common denominator. We're going to multiply the top here by g at x. Okay, so we have g at x, f prime at x equals g prime at x, f at x. Okay, and that's all over. We just gather those two denominators. G at x times g at x, which is g at x squared. Okay, that's the proof. This is actually the formula that we're going to be using for quotient rule. In short terms, it's u prime v minus uv prime all over v squared. It's important that we do this in order because there is a negative now. It's not just addition. Now we're just going to do three examples here. So I'm going to call the top u and the bottom v. And just to recall, u prime v minus uv prime over v squared. Okay, so what's the derivative of h at x? Derivative of u is just 3. Write the bottom as it is, minus the top as it is, times the derivative of the bottom, which is 2x. And that's all over v squared. So we have x squared plus 5 all squared. Okay, I would personally collect some of the top at least. We have 3x squared plus 15 minus 6x squared plus 8x all over x squared plus 5 squared. Okay, I would leave the denominator as factored form. That's totally fine. 3 minus 6, I get negative 3x squared plus 8x plus 15 all over x squared plus 5 all squared. And that's it. Okay, same thing here, but we're actually going to try to find the equation of the tangent, the entire tangent at x equals 0. So we know x equals 0 is just 0 over 1, which is 0. So our point that we're trying to find, our equation of the tangent is 0, 0. Now, let's do y prime. We'll call the top u the bottom v, and remember u prime v minus uv prime all over v squared. Okay, the derivative of the first times the bottom as it is minus the top as it is times the derivative of the bottom all over the bottom squared. Now, we can simplify the top, but it really doesn't matter because we want to sub in 0 anyways. So 2, 0 plus 1 is just 1, minus, this all goes to 0. Okay, over 0 plus 1 squared, I get 2 over 1, so I just get 2. So therefore, when we're trying to find the equation of the tangent, we get, that's b equals 0, because that just goes down to 0. Therefore, equation of the tangent is y equals 2x. And that's it. Okay, now let's determine the coordinates of each point on this graph. So again, u and v, where the tangent is horizontal. Okay, so we want u prime v minus uv prime over v squared because it's quotient rule. Okay, so and what we eventually want to do is we eventually want to equate it to 0 because we want to know horizontal. This is when m equals 0. Okay, derivative of the first is 2 times the second as it is. So let's put x to the 1/2 minus the first thing as it is. So 2x plus 8 times the derivative of the second. That's 1/2 x to the negative 1/2. And that's all over x to the 1/2 squared. Okay, again, you can sub in, yeah, let's break this down because we're gonna have to equate this side to 0. So this is 2x, this is gonna be 2 root x minus, and let's actually expand this. So this 1/2, I'm gonna put the root x on the bottom. Okay, so I have 2x over root x plus 8 over 2 root x. Oh, that's 2 root x. And then that's all over just simply x because those cancel out. So I have 2 root x minus, so for these, 2 divided by 2 is 1. And then x to the 1 divided by root x, we just subtract the exponents. So minus root x plus 4 over root x. And that's going to be divided by x. So let's find a common denominator. We're going to multiply this by root x over root x. We're going to multiply this by root x over root x. And we're going to leave this. So I get 2x minus x plus 4. This is minus 4. Sorry, because of this. Okay, minus 4 all over root x. And this is going to be times 1 over x. So what do we get? The top stays the same. Well, 2x minus x is just x, and then minus 4. Okay, and this is x to the 1/2. We're multiplying it by x to the 1. So what we're going to do is we're going to add the exponents. I get x to the 3 over 2 on the bottom. Okay, our question asks, when is this slope horizontal? Okay, so our question is, when is x minus 4 over x to the 3 over 2 equal, when does this equal 0? Well, when we multiply, cross multiply, this just goes away. So when does x minus 4 equal 0? Bring that over. We get when x equals 4. If a question specifically asks for the point, then what we have to do is plug that 4 back into the original to find where the point actually lies. Okay, so we get 8 plus 8 is 16 over 2. Okay, so the point is at 4, 8.